Hello everyone, this is N. Kavita, working as Assistant Professor in Department of Electronics and Instrumentation Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this specific presentation, we are going to see a topic on PN junction diode, which is the basic part of the electron devices. This presentation will include the following content. Initially, we are going to see what is a PN junction diode and how it is being created, and how the formation of PN junction occurs in a diode. Followed by that, we are going to see the operation of a PN junction diode under forward bias as well as in reverse bias condition. What is the characteristics between voltage and current, followed by applications of PN junction diode. First, we are going to see what is a PN junction diode. A diode will be having two electrodes in it, namely anode and cathode. When you observe here, we have got a symbol like a triangle. The one terminal is called anode, the other terminal is called cathode. A PN junction is created at the junction between a p-type material and an n-type material. And these two terminals and one junction together create a diode. It is called a PN junction diode. It is always noted that the p side of this is made up of a positive type, and this p-type material is always enriched with holes, which is the majority carrier in case of p-type material. Whereas in case of n-type material, it is made up of a negative charge particle, and this will have excess electrons. So in case of n-type material, the majority carrier is going to be the electrons. The interface or the boundary between the p-type and n-type material is called a PN junction. Next, we are going to see how the PN junction is being formed. As I told you already, we have got a p-type material which is all enriched with empty holes. We have got an n-type material which is made up of free electrons. What happens usually in this specific cases, there will be a junction which is created between a p-type and an n-type material. And now let us see how the junction is being created. When you observe in the intermediate position, we can see that there is the charge particles, that is both electrons and holes gets accumulated in a specific region. This p-type will have holes which is of positive charge. This n-type will have electron which is of negative charge. Initially, when these two dislike charges happens, they get attracted towards each other. So the positive charge particles in the p-type will get attracted towards the n-type material, and the electrons in the n-type material will get attracted towards the positive charge in the p-type material. It is always to be noted that the concentration of electrons and holes in p-type and n-type material is not same. So what happens now? The electron which tries to cross over this junction and meet the p-type material, and the excess electrons are stored in the middle position. Similarly, the holes in the p-type material which is of positive charge gets attracted towards the n-type material, and it gets stored in the middle position. So this region which is made up of this charge particles is called a region, and that is called a depletion region. This depletion region is depleted of a charge carriers, and these charge carriers are highly immobile. Now we are going to see the biasing condition of the PN junction diode. Biasing is nothing but providing an external power supply to a device. So there are three cases which are observed here. The first condition is called zero bias condition, which means I will not apply any kind of external voltage to the PN junction diode. The second is forward bias. What happens in forward bias is the positive terminal of the battery is getting connected to the p-type material, and the negative terminal is connected to the n-type material. The third part is the reverse bias, vice versa. In case of reverse bias condition, the negative terminal of the voltage is applied to the p-type material, and the positive type is connected to the n-type material. We will see the zero bias condition. When no external voltage is applied to the PN junction diode, actually what happens is, as stated already, the electron will be diffusing to the p-type material. Simultaneously, the holes will diffuse into the n-type material. They'll combine each other. Because of this, an electric field is generated by the charge carriers. The major thing which is to be observed here is the formation of depletion region. So this electrical field will oppose the further diffusion of charge carriers so that there is no movement of charge carriers in the middle region. This region, as I have told you already, it is called a depletion region, or it is also called a space charge region. The next condition is the forward bias condition. In forward bias condition, the P region is connected to the positive terminal of the battery and N region is connected to the negative terminal of a battery. So in this specific forward bias condition, what happens is this will act like a kind of closed switch. That is, it can able to make the current flow from anode to cathode, and let us see how does it happens. So when a voltage is applied to this P-type material and N-type material, due to the attractive force, this P-type is made up of holes which is of positive charge. They get repelled from the battery and attract towards the N region. Similarly, the electrons in the N region gets repelled away from the negative charge carriers and they get attracted towards the P-type material. So what happens here is, because of this, the depletion region width will get very small, since the electrons will get attracted towards the P-type and the holes will get attracted towards the N-type region, and since the depletion region will be getting very small. So in this region, there will be a flow of electrical current because of the movement of the electrons in a closed path. So I can say that under forward bias condition, my PN junction diode will act like a closed switch. That is, it is capable of providing the current which travels from anode to cathode. The next condition is a reverse bias condition. In the reverse bias condition, the P region is connected to the negative terminal of a battery. N region is connected to the positive terminal of the battery, and you know that this is made up of electrons which get attracted towards the positive terminal of the battery. P region is made up of holes which get attracted towards the negative terminal of the battery. Since they get attracted towards each other because of the movement of the electrons and currents, both the charge carriers will start to move away from the junction. So in reverse bias condition, the depletion region will get wider. As this depletion region is getting wider and wider, we can observe that the condition is said to be the reverse bias condition. In such a case, there will not be a flow of current, or I can say there is a minimum reverse current which is flowing inside the circuit. In this condition, I can say my PN junction diode will act like an open switch, which means it cannot able to flow the movement of electrons which will lead to the current. So due to this, there is a reduction in the number of positive and negative ions in case of reverse bias condition. So it is very clear that in case of a PN junction diode, it always operates in the forward bias condition, whereas in case of reverse bias condition, a reverse current will start to flow. We will observe the characteristics of a PN junction diode. So when you observe the characteristics between the voltage and current, it is very evident that the current flows only due in the forward voltage. You can observe here. So during the forward voltage, there will be a flow of forward current which is in milliamps. When I apply a reverse voltage to the PN junction diode, there will be a reverse current which is in microamps. You can observe initially when the diode is said to be in forward bias condition, the current starts to flow, and after a specific point, what happens is the current increases drastically. So this specific voltage where my current is starting to increase rapidly is called as a knee voltage. So this knee voltage may be 0.3 in case of germanium, 0.7 in case of silicon. So now we have to observe what happens in the reverse bias characteristics. So when my diode is connected under a reverse bias condition, obviously there will be a flow of current which takes place in the reverse direction. You can observe that the current is getting decreased in the reverse direction, and the specific point where my current is dropping out suddenly is called a reverse breakdown voltage. So as far as breakdown is concerned, what happens in breakdown is actually the covalent bond between the electrons is getting distracted or it is being detached and the recombination occurs, and because of this breakdown of the covalent bond, there will be a breakdown which occurs in the reverse bias condition, and this breakdown is called Zener breakdown, And there is another breakdown called avalanche breakdown. In case of avalanche breakdown, there will be a multiple breaking of the covalent bond, and this region is called avalanche breakdown. So it is very evident from the voltage current characteristics that only under the forward bias condition my PN junction diode will start increasing the current. Whereas in case of reverse bias condition, there will be a steep decrease in the current because of the width of the depletion region is higher, and there will be a flow of a reverse saturation current. So where my PN junction diode find its application? We have got many applications. The first application is a rectifier. It can be used to convert an AC into a DC. This PN junction diode is used in case of photodiodes, a solar cell, in electrical switches, photovoltaic cell, and light emitting diode. Hope this video helps you to understand the basic conditions and basic operation of a PN junction diode and how it is applied and how the current flow happens. Thank you for watching the video.